going to give you some extra help here for activity 2.1. This chart lists all the elements that are going to be in these equations, and here's their exact mass. And according to the instructions up here, when adding these, keep them to 4 places past the decimal point, do not round. So I come down here, the mass input would be the mass of all the reactants. The reactants are all the elements in front of the arrow. So in example 1 here, I have 3 helium atoms. So I want to go up and find the mass of helium, which is 4.0026. And since there are 3 of them, I'm going to take that and multiply it by 3. So you do that in your calculator, 4.0026 times 3, and you get 12.0078. The mass output is a single carbon atom right here, anything after the arrow. So I go up here and look at carbon. It has a mass of 12.12340 zeros. Now it wants to know the difference between the input and the output, so I'm going to subtract these two on my calculator, and I get 0.00078. That's one too many zeros, 0.0078. And lastly, how does the mass input compare to the mass output? How does this mass input here compare to the mass output here? And you can see that the mass input is greater than, so we're going to type greater than here. Okay, let's do one more as an example. Now we're going to take this one. Everything in front of the arrow is the mass input, so it's a helium and a carbon. So I go up and look. Helium is 4.0026 plus a carbon, which is 12.1234 zeros, and I get 16.0026. So that's the mass input. The mass output is everything after the arrow. In this case, it's only a single oxygen, and that's listed right there as 15.9949. Again, you just take the mass input and minus, or to get the difference, you have to subtract them. So 16.0026 minus 15.9949, and that equals 0.0077. And again, you ask here the same question: how does mass input compare to mass output? Here's the input, here's the output. The input is definitely greater than, G-R-E-A-T-E-R, than. Do the same thing with these next two examples. The only thing different is when you get to this line down here, the product is sulfur and a neutron. So you have to go up here and add to get the sulfur mass and the neutron mass to get the output on this side. All right, now see if you can do this, the rest of this on your own.